Hello, Andy, and welcome to Computer Science Chats. How are you?
Good, thank you. Nice to meet you, Victor.
Thank you. So I have several questions for you. First, could you please describe and introduce yourself and describe your educational background?
Sure. My name is Andi Gavrilescu. I'm currently an engineering manager in the Core ML group at Google in the Seattle area. I received a master's degree in 1992 from the Technical University of Iași in Romania in computer engineering.
So what inspired you to pursue computing as a career?
I guess I was pursuing something that I was passionate about and would be relevant in the future. Initially, I was interested in pursuing a career in electrical engineering. And yeah, during high school, I was tinkering with circuits. I was building music amplifiers for my cassette player in the car or a tape player. At some point, I discovered digital circuits and it was fascinating what I could do with them. And so, yes, I was ready to apply for the electrical engineering. And then a family friend told me about this new department of computer engineering at our university, and then how computers and automation is going to be the future, and said, yep, maybe that's a good idea. So
Thank you very much. Could you describe some of the activities that you do through your work?
Sure. So as an engineering manager, I balance technical and people management activities. And one exciting part of computing is that it continuously evolves and we never get bored. There's always a new technology to learn. There's a new area to innovate. In the past years, I've been passionate about semantic understanding of texts and conversations. I'm now interested in training this very large language models that are being used in language understanding and in conversations. As a people manager, I am constantly looking to find ways to enable people to achieve their career goals while working efficiently together. So continuously refining ways of listening to people and helping them answer their career growth questions and helping them overcome their obstacles.
Thank you. So what do you like most and what do you find most challenging about these activities?
I really enjoy the continuous learning and the opportunity to help contribute to some of the important advancements in computer science. And like I had a chance, for example, early in my career to work in Windows and working on networking protocols and help invent and innovate some of the Wi-Fi technologies that we use today, or work on firewalls that we use today. So that's one part of being able to impact the society through some of these contributions. The second part is that to achieve these breakthroughs, you generally need involvement of large teams, and these large teams tend to depend on each other. And one challenge is to try and break or reduce the dependencies. So we try to make people, individuals, make progress independently and being autonomous without having to have deadlocks between them.
Thank you. So what part of your education or experience most help you with your current work as a managing director?
That's a good question. I would say a lot of it. So on the management side, a lot of it was actually developed over the years. On the technical side, I would say a lot of it was some of the fundamentals in physics and math, I think I was reflecting that I used a lot of the math that I've done in high school and college, from geometry and linear algebra and calculus and to matrix multiplications and so on. So yeah, the time when you were studying, there was like, hey, when I will need all of this, and turns out that yeah, at least for the math part, is really was really useful. But that's on the management side, though. I think an area that people should pay attention to is maybe in high school and college, how to speak with people, how to engage with people. Um, yeah, I know that some high schools have classes on how to create a speech, and so that, yeah, paying attention to that is important.
Yeah, so I understand that before you were in more of a development role. So how would you describe the transition from development to managing people?
I think that's a progression, which maybe early on in my career, or I would say 10, 20 years ago, was more relevant. I would say nowadays, you can make, and it was generally inspired from the need to have a higher impact. So as you become, as a single developer, you can only write so much code. Um, and by becoming a manager, you can help drive and manage a larger project. I would say that our industry, though, has been going through transformations in the last 20 years or so, where the traditional management model, which was created in the industrial era, where you would have some um, person that knew how to manufacture shoes, they would decompose the process and give a little piece to a small team, then they will supervise the entire process. I think in computer science, this is not applicable anymore. And I think the managers are becoming more like cheerleaders, and you just need to help people work together. And they can be technical influencers, and they don't need to be managers. And I think we see this in all the large companies now, this management and technical lead being more and more separated. So yeah. So manager was more as a way to have an impact, but I don't think that's necessary nowadays.
Thank you. What advice would you have for high school students who would like to get into your field?
Yeah, first, don't skim on the math classes. But then make sure that this is something you're passionate about. This is probably true for any field you're going into, because you'll be spending majority of your day in doing this. I would say for computing in particular, but even in general, make yourself comfortable with change. If we look in the history, you observe that the rate of change has increased exponentially, right, in the late. And this is especially true in the computer industry. I gave you the example, for example, of how management changes, but it's also how people engage with each other, right? The pandemic showed us a different way of working together, which people that are involved in computing, they were able to adapt and adjust, and they continue to work in this new model. Other industries needed the in-person way, but third, I would say, or fourth now, maybe I would say, try to keep yourself relevant in the industry by anticipating where the industry is going to go. I used to play this game where I would say, well, I think in the 2 years, this is going to be important. And then 2 years later, I would look, okay, was I right or was I wrong? And I'll give an example where I was wrong. I could never believe that pictures could become digital. Because I thought that we will always need to print them. So that was an example where I was wrong. But anyway, give it a try. But the idea is to try to be prepared where the industry will need your skills and your knowledge. And by doing that, then you'll always be relevant.
That's very interesting, and it leads into my next question. Where do you think that computing is going to go in the future, and how can students prepare for it?
I think this is a very loaded question. So from my humble vantage point, I'm excited to see the progression of these very large machine learning models, this very large language models that are progressing in representing abstract concepts, so that they can be used in, and then they bring improvements in language understanding, text generation. Like you can, for example, give some of these models half a phrase and they'll generate a full article for you. Of course, the articles are still crude, but we're making progress there. They can solve now the reasoning challenges like problems, arithmetic problems for 5th grade. Or they can even generate code. So they can generate Python code from natural language instructions. So we expect these models to keep growing and becoming better and better. And we also see this way of using these large models that incorporate this knowledge, general knowledge world, evolving not just from language, but to images, vision, and multimedia in general. We'll probably see efficiency improvements in ML training and inference, and probably also coupled with advances in hardware. So we'll see more and more of this ML pushed into the periphery and mobile devices, in watches, and of course, cars and other specialized devices. Of course, we're all waiting for the self-autonomous cars. So that probably will see a lot of other vehicles like carts and lawnmowers and whatnot. That I would also personally be very interested to see where quantum computing will take us. I don't know, will it become practical beyond just the currently predicted financial and science applications? I'm really curious where that's gonna land.
Thank you so much for meeting with me and doing this interview.
Absolutely, and good luck on your quest, and hopefully we'll see you in this field.